Hello everyone, my name is Thanaphon Bung Toeng. Today I would like to present the transition pattern detection of streaming natural data. About the agenda of today, firstly I would like to introduction about the streaming natural data and transition pattern detection. The secondly about the related work. Third is about our methodology. Then experiment of our research. Finally, conclusion and future work. Let's start with about the introduction. The data streaming is continuously generated and often changed over the time. Our research focus about the data intensive discovery is to start the online algorithm from classification or discovery in streaming natural data. About the streaming natural data, it can be useful in natural science application, discovery, and learn natural behavior. For the example about the methodology, astronomy, geology. So we would like to apply the mining process with the streaming natural data. Our objective of this research, the first study about the dynamic nature that is created into the infinite sequence instant about to learn the unknown transition pattern happening. The secondly, avoiding false alarm is create the worst result and it occurs people to disregard the future alarm. The definition about the abnormality. The abnormality derives from the normal situation or the expert behavior. The second is the change point, the point when the significant change happens. The transition pattern is the short line or the temporal burst of pattern. About the model-based transition pattern, this type useful for predict after anomalies in which the data change over time. The data streaming like this is the xt plus 1 until the xt plus n. The data streaming is become the model is compute and learn to find the transition pattern. After that, we use the previously version model to update to become into the new version for learn the new instance is coming. For the example about this, let's start with the AT. The AT is the square pattern like this. This is a normal situation. Then at the TB, the new instance is coming. It seems the significant change, but when you compare the sliding window with the previously data, so it is transition pattern or not. In actually, it's no. This is a noise. Then after the TB, we found some similar from previously version. Then at the TC is a new instance is coming. Is this transition or not from previously version? Yes, it's actually it's like the transition pattern. Then the correct. This is a transition pattern. The significant change the pattern. So we did not know the new instance is coming. The new instance is coming is independent from the previously version like this. So the challenge of pattern detection. The firstly, we cannot collect a huge of data stream for prediction. That is why data handling is important. The secondly, about the historical data may not predict the future behavior. When should we need to sync a collection of data? How much do we need to sync a collection data? And finally, about the forest alarm, because the data stream of natural science application frequency contain the noise. That is why we need to reduce the forest alarm. About a related work. About the predict model based on machine learning approach, the firstly about the box based experiment is a work group from the classifier that work together to improve the format. The second is about the tree based algorithm, but it is a dynamic tree to classification like the decision tree. Then about the karma filter, provide the estimate of unknown variable, give the measurement observed over the time. An adaptive side window is a dynamic change strategy for the correct of the sample handling. And the key main idea of our research about the tail-bound equality. A tail-bound equality is a common statistic approach for change detection in data streaming. Many tail-bound in our research. Many tail-bound in related research. For this case, this is an example of a tail-bound. Firstly, about the Chebyshev equality, Hofstadter inequality, Bernstein inequality, McDermott inequality. Why I select the Chebyshev inequality? In our environment setting, we have the stable mean, so we need to find a new instance is outside the confidence bound. I will explain the confidence bound later. The confidence bound is become to the mean and standard deviation. So if the new instance is coming from outside the bound that it creates from mean and expect value is k real number multiple with the standard deviation. This is why I use the Chebyshev inequality. The Chebyshev inequality was firstly used for the change detection by Ferrari-Mann and colleagues in 2005. In this year, on May, we found the Chebyshev inequality to apply with the streaming ratio data. The data is generated by light ray effect on the observation. Then the Chebyshev inequality find the confidence bound. However, they aim the offline algorithm is not data intensive algorithm. So this is the confidence bound. If new value instance is outside bound, we assume the change point. But if in the bound, we assume this is not change point like this. The bound is calculated by mu with the k value and standard deviation like this. Our work we forgot about the mean and variance calculate with the instance of the sliding window. However, we didn't know the suitable of the sliding window. So then we apply the dynamic strategy of the window size for mean and variance calculation. It's called the adaptive window size. Our methodology. We have about the three main ideas. The firstly about the Chebyshev inequality to give the confidence bound. The secondly about the sliding window technique. We have two kinds of sliding window. Firstly about the fixed window size and adaptive window size. And the third about the two-phase maximum alert is useful for the reduce the false alarm. Let's start with the baseline algorithm about the Chebyshev inequality with the fixed window size. The Chebyshev inequality is the key idea to keep the probability bound. The new instance are not outside the bound. The Chebyshev inequality is calculated in the line number 9 like this. So then the fixed window size. The fixed window size structure is first in first out or FIFO. The first in first out is the structure to handling data in the line number 5 and line number 6 like this. So this head in example, let's start with a new instance with the xt is 100 and previously version is 4 instance. About the calculated the mean and standard deviation and variance like this. Finally, we about the 87 more than the 73. So then we become to a new instance is coming. The 50 is pop outside the window file. Then the new instance is xt plus 1 about the 85 like this. The calculation in the right hand side. But the left hand side, the 87 is more than. In this case is the published alert. However, in this case, no, it's not true. It's published, is no alert to publish like this. The problem of the fixed window size, we did not know how long the transition happening. If we use the short window size, maybe the information is not enough. However, if we use the window size is large, it may be not detect the transition pattern. In this case, we assume this is a normal situation like the square pattern like this. Let's start with the each example. So in the MUT like this, we assume the 5 is the change point. Then in at WT plus 3, the 0 is coming. It's different from the 555 is a change point like this. Then at the WT t plus n like this, define the change point again. However, if we look, all of them is not the transition pattern. But if we use the lag of the window size is like this. So the zero like this, new the instant it's not the transition pattern because all of them is the all window have the similarity mean. So a new instant is coming is not the impact to change like this. So we apply the strategy about the dynamic window size like this. When we identify the change point, the window size is become to a lag like this. When the T3, the window size is large, and we find the concept of dip or change point, the window is shrink into the new window size like this. After that, we shrink again at the T4 like this. The adaptive window size in the right hand side is the main routine. We use the Chebyshev inequality in line number 3 to find the change point. When we found the change point, the iterated the WT. However, if we did not find the change point, we update the window size by adding in this case. And the right hand side is the algorithm of adaptive window. But adaptive window and the fixed window size, we found about the frequency detect when the noise public. In this, we assume the xt is a noise and the ty and tz is a normal situation. Then the tx is public alert because the change point. Then the ty and tz following this. So, however, we assume if we public the single alert is become to the noise. But if we found many alarm in the short time, we assume this is a true alarm. So this is the situation. We need to propose the second window for reject again like this. So in the 9 is a change point. So in this case, we found many zero. Zero is mean not change point like this. We public the change point. Then the primary window will public alert, but this is a single alert. Then we found the second alert. The second window is public 1 again. The final decision is alarm like this. Then the new decision is become again. So the second window is public alarm again like this. The two-phase mechanism. The two-phase mechanism is used to judge again from the Chebyshev to reduce the false alarm. We introduce the second window to readjust again. From the two-phase alert mechanism, we propose this formula. PT is the probability of the false alert that generated by the Chebyshev. RT is the number of alert. And sigma prime is a donation and division of the false alarm. However, the standard deviation is the binomial distribution in this equation. So, our methodology, we have two main kind about the baseline Chebyshev inequality, adaptive window with the Chebyshev, and finally about the two-phase mechanism. All of them be implemented from the scikit multiple API. This is open source. About the experiment of our research, the dataset we use a Poisson distribution dataset. The light curve is the from the Poisson dataset. The secondly about the dataset from HiNet. This is the seismic station in Japan. The characteristic of the transition pattern, we have a T-kind type about sine wave, triangle wave, and square wave. Duration of transition, we have the 100, 500, and 1000. The height of the peak is a 1 sigma, T sigma, and 5 sigma. The sigma is the net of division of the transition pattern over the tensor dataset. This is a sine wave pattern and square wave and triangle like this. About the duration, about the 100, 500, and 1000 like this. About the height equal sigma is nearly is not the change point. Is become to a normal situation and 3 and 5 sigma like this. This is the result of our experiment insert. In the left hand side is the Chebyshev with the fixed window size, and the right hand side is Chebyshev with adaptive window size. We divide about the 100, 500, 1000 duration, and 3 5 about the height. For this example, in this bar is mean the Chebyshev fixed window size duration is 100 and height is 5 sigma. So we found the problem in adaptive window about the 100 duration and 1 sigma at height. But however, the false alarm is reduced about the 56%. The fixed window size problem. So we introduced, we didn't know about the situation of transition patterning happen, how long it is. So in this case, when we use the window size is equal the duration in this, we cannot detect the significant drop like the square pattern in this case. The impact of the high duration in this case, we found the Chebyshev inequality has many alarm like this. So we reduce by the adaptive window this case in the same time. So the many alarm is reduced to the short time like this. But however, when we use about a two-phase mechanism, about the false alarm in the left-hand side, it reduced about the phase 80% and 75%. However, but the two positive is become to reduce. Why this case the problem I show into the next slide. In this case, in the right hand side is about the result from adaptive window is the single alarm. So then we proceed by the two-phase mechanism is removed because the single alarm we assume this is a noise. That is why the two-phase mechanism about the 100 duration and 1 sigma is have become to a problem. The conclusion and future research. We apply the Chebyshev inequality to confidence value for the change point. The second about the window size is important part for the change detection. About the false alarm reduce, the window size effect on the transition pattern detection. The anomaly in natural size is hard to predict what happening or how long it is. So the future work, we need to apply the real light curve dataset streaming in the astronomical field with the optic and infrared time domain astronomy group at the University of Tokyo. Secondly, we need to improve the aggregate technique for all pre-processing to improve the accuracy, like the binding algorithm or two-phase mechanism. That is the end of present. Thank you.